Hello, everyone. Welcome to this webinar. It's about managing IT projects effectively. Hopefully, we are going to spend some time talking about the uniqueness of IT projects and how to manage them properly over all different methodologies. I think that can help us doing this. My name is Ala Elbaz. I'm a partner here with Meirc Training and Consulting. This is a little bit brief on background about myself. I have a bachelor degree in mechanical engineering and also a master's degree in mechanical engineering from Kuwait University and University of Jordan. I have MBA from Wayne State University in Detroit, Michigan. I'm a certified PMP and I'm also Agile certified professional and PMI ACP. I worked before in different organizations, including Chrysler and General Motors and Ford Motor Company. And primarily, I worked as a project manager, and I worked the last few years actually. And when I used to work for Ford, it was in the IT department. I worked on infrastructure and application development. I've been working with Meirc here in Dubai in the last 10 years, and we are and as a management consultant, and currently I'm a partner with them. And once again, this is a little bit brief about myself. I've been seeing messages about, I think from Javier saying hello everyone again. Yes. What are we going to talk about in this, like probably 20 minutes or half an hour? We are going to talk about the following. I'm going to start off about why managing IT projects is different. What is the unique things about IT projects? What are the common challenges that we see in IT? We're gonna talk about the system development life cycle, and then we're gonna just present the different models that we use usually in IT projects, including Waterfall, iterative, incremental, and agile. After that, we're gonna talk about general framework of for IT projects. I'm gonna single out requirement gathering and talk about a little bit more details. We're gonna talk a little bit from a very high level about project planning, and finally about implementation and delivery. Again, it's going to be extremely high level. Let's start off with why managing IT project is different. Project management. A lot of people argue that project management is project management. You can apply it everywhere, whether it's in construction or IT or pharmaceutical or whatever industry it is. However, the reality is, although it's probably true that the concepts of project management do not change much, but IT specifically has some uniqueness or a little bit different than other industries. IT specialists, IT, and any other knowledge areas. The reason for this uniqueness is the risks that associate with IT projects are different than the risks that we see in other types in other industries. IT, for example, have one of the major challenges, the problems that we face, and the risks that we actually run into is the obsolescence, that the IT keep evolving and the old technology become obsolete very quickly. So a lot of time, if the project is a long project or takes a long time, then by the time we are finishing the project, it is already obsolete. Compatibility is another issue that we don't see in other industries. Technical difficulties, of course. There is a high dependencies between different projects in IT. And finally, of course, the rigorous schedule risks. There are special challenges, as we're going to see in a few minutes, that usually very special for IT, like compatibility, can be, if you will, scaling issues and things like that. And finally, the methodologies that we use in managing IT projects are different than the one that we see in manufacturing, production, or we can see in other construction or other industries. As I promised, the common challenges we see in IT projects, like incompatibility, the need for integration of technology. One of the major problems that we face in IT is the technical language that IT departments use versus our business processes and business requirements. And sometimes we have a disconnect there. Quick changes in technology, as we said, non-scalable technologies, loss of data, Another major problem we face quite a bit is the virtual teams. And IT specifically, a lot of time we see situations where the applications being developed in the other half of the world, and you can have a project that the resources are spread all over the world. So how can we connect with each other? Again, it's another important thing that we need to probably to explore. It's very easy to have a communication breakdown in IT projects, and the reason for that is IT normally solutions are not tangible. So sometimes we have problems in understanding for example, the requirements of the client, or even translating that to something really what is what the client really wants. So a lot of time we have communication breakdown, and that's something that really need to work on and need to be addressed very properly. This is alarming statistics. I just show it. It's maybe not very recent statistics, but it's a statistic that's been done, and it shows only 1 out of 4. Maybe the numbers are not extremely precise, but the important thing here is really 1 out of 4 here is just, we can call IT project is successful. And being successful is basically on time and within budget. The rest of them is truly can be considered either as either challenged or even failed altogether. Failed, did not deliver at all, or the project is being terminated. So this is very, very low actually successful rate, and compared to other projects, it's actually IT is worse than other projects in different industries. And that's why there are some, there is a need to manage the IT projects a little bit differently than other types of other projects in different industries. So having said that, we'll start off with talking about system development lifecycle, or which is basically, it's a conceptual model used in the project management overall. And it is basically focused or describes the stages, the different stages that the project go through, the IT project go through, from the very beginning, the concept or initial feasibility study or business case, all the way until the project is completed and turned to the operations. So what are the different steps and how can we manage them? So there are different schools that can help us doing this. For example, we have those are the 4 common, maybe different approaches we usually use in order to manage projects. Every one of them has maybe its own advantages and maybe a little bit of their disadvantages as well. There is no one is probably much better off than the others. Those 4 are the waterfall, which is very common, very classical, older methodology. We use it normally for larger size projects. Iterative approaches, which is we use them a lot of time if we are not sure about the requirement and we need to go through different iterations in order to be able to understand what exactly the customer wants. The incremental, we use it when we really need to build the solution bit by bit. And finally, the agile. And the agile is truly a combination between the iterative and the incremental. Although we are talking about those 4, the most common ones that we see today are the waterfall approach and the agile approach. But let's take a quick look at each one of them. Let's start off with the waterfall approach. Waterfall approach, as I said earlier, is probably one of the older ones, older methodologies, and it's been developed in 1970. It's actually, when it started, it came off like construction, so it was similar. It started with construction and manufacturing, and then of course been updated to fit IT solutions. But the reason we call it waterfall is usually the progress usually goes like or flows, if you will, steadily downwards. It's exactly like a waterfall. So usually go through phases. Those are example for the phases. For example, we can use conception, initiation, analysis, design, construction, all the way until maintenance. So it looks actually something like this. So we start off with system requirements, where we gather requirements for the system, then system design, and then it flows down software requirement analysis to preliminary design to detailed design, coding, subsystem testing, and finally system testing. As you see, it goes from one phase to another, like exactly similar to any classical framework or classical methodology. But the difference a little bit between the waterfall, maybe the strictly classical one, is we have those little loops or feedbacks. So for example, we start with the system requirements, and then we go down to system design. Sometimes when we do the system design, we find out that there's probably a lack in the requirements. So we need to go back to the system requirement phase in order to get what the missing requirement, all the missing requirements, and goes like and so forth. So this is usually it's best. We usually recommend the waterfall approach, or it's usually best bet for all those projects that usually are larger in size and usually goes for a number of years. This is probably better off to use. We are much better off to use this waterfall approach. As I said earlier, the other different types, the incremental. Incremental is used as basically we are decomposing the whole project into smaller components, and then we are designing and actually developing each component sometimes at the same time and separately, and maybe in parallel as well. So as we see here, we gather the requirements from the customer, we define them, and then we start design. However, the design, once we start design, we start breaking the design into maybe different components. So every component will be designed separately, but there's a specific team will be responsible for designing that particular components. So the team will do the component, and then they do the low-level design, they start the coding and the unit testing, and finally component testing. And after all the components are done and developed, then we do the system testing altogether. The product will be defined as finished when satisfy all of its requirements. So that's how the incremental model works. So in the incremental, as we said, the project is, or the solution is developed bit by bit, piece by piece. On the other end, another approach which is also popular is, we call it iterative approach. The iterative approach is used when the requirement is not fully defined or understood, or it's really vague. So if you have a customer who asks you to develop a solution that's not extremely clear, so we use actually this approach where we start by gathering, requirement, defining it, design, code it, and test it, and then we have like a prototype. We can show it to the customer. If the customer doesn't like it, then we go again and do the same, do iteration 2, and and iteration 3 and 4, until the client is happy, where we finalize with the system overall testing. Those two approaches, incremental and iterative, used to be really popular, but lately the one that's becoming really popular nowadays, especially in IT atmosphere or IT environment, would be the Agile Development model, which Agile combines both its iterative and incremental at the same time. So we use both methodology. We take components bit by bit, piece by piece, and we develop it by iterative approach. It's really very Agile is probably one of the most, or the most flexible and interactive methodologies we usually use. It's a process where we manage it, or develop it, manage it, and implement it in small chunk of work. So we take smaller, like actually what we do is we take the whole project, we divide it into features, and we take each feature, we divide it even to smaller units like user stories, and we take those user stories and develop them one by one. And we keep the customer engaged, and if the customer is not happy, we go through first iteration, second iteration, all the way until the customer is satisfied. So it's really what I like to call it, the project management of the future, especially in IT. This is a nice picture. I like to show it when people are more intrigued about Agile and the difference between the classical one, which is Waterfall, and the Agile. I love to show this picture. In Waterfall, it's like if you are doing this drawing. In Waterfall, the requirement is gathered, well defined, The planning is done, the design is complete. Now we want to implement. We just implemented, but we start drawing the picture properly as it's supposed to be. At by the end of the time, when you're done drawing, you're done from the project. On the other end of the spectrum is if you are using Agile, and if you're talking to your customer, you're not sure about what he's looking for, then you do a little, you talk to the customer, you listen to him, and then you basically sketch something, and then you show it to the customer. And the customer will look at it. So you know what? Yeah, but I'm not sure about this. For example, if you look at the first picture, the lady putting her hand in her mouth. And you tell her, no, this is not exactly what I'm looking for. I want her just probably to have her hands down. So he does, you go through the second iteration, and then he look at you, he told you it's going to be in colors. So you do the third iteration. Then he told you the hair is not maybe blonde, it's probably black or dark, and go all the way, and you keep refining your solution until you get to the point that you're really basically what the customer is looking for. Core principles we see usually in Agile is the one major difference is that between the Agile and non-Agile is Agile truly we embrace change. We welcome change. Actually, changes is a very important part of the process here. So while in the classical we try to limit the changes, or we try to control them, or sometimes try to be radical, and sometimes try to eliminate those changes altogether, in Agile we actually encourage them. So that's one of huge difference between those Agile and non-Agile. In Agile, we work in small chunks, as we said. We call them value added. There should be a value, and actually we develop the highest value first. And that's actually part of the incremental mentality we have there. We use build and feedback loops all the time. We encourage learning through discovery and experimentation. It is a value-driven development. We encourage failing fast. So failing fast from the beginning of the project is better just to wait all the way until the end of the project and then fail, which costs us a lot of money. We encourage continuous improvement, and that's actually a very essential thing in Agile, and also continuous delivery. So Agile project management is best suited for IT specifically, or knowledge-based projects. We also see it in non-IT, but usually in IT is becoming very popular. And as I said earlier, for a smaller size and medium-sized IT project, it is the project management of the future, if not currently. This is another way to look at Agile. In traditional project management, we usually have certain scope, and the scope has to be done within time and cost. Sometimes we are flexible in terms of time and cost, as long as we are delivering the scope to the customer. In Agile, actually, it's totally the opposite. We usually, the time and the cost, we try to fix it, and we try to develop the functionality and the feature according to the customer requirements. And sometimes we end up not developing everything the customer wants, but we deliver for him the most important feature. And again, this probably will be happy if we deliver 80% of the feature he's looking for. Again, in IT, we all know that most of the features that we have in our solution, a lot of time we do not even use them. So that's why if we deliver the most important one or the highest value, the customer will end up be happy, and we'll be able to meet our budget constraints and time constraints. Agile, of course, is a mind or it's a framework, but there are certain specific methodologies that follow Agile. The most important ones are Scrum, Extreme Programming, Lean Product Development, and Kanban. Probably the most common ones are the first two, the Scrum and Extreme Programming. A lot of time we also, sometimes we can come with methodologies that combine both of them. We're not going to go into a lot of details of this. This is just to give you, because this is, as I said, is the trend now in IT. So I just want to show it to you very quickly because it's very related to IT project. Let's go back here to classically, probably talking about managing IT projects classically. So what do we normally do? So this is what I like to call it the life story of projects. So what happens is before we start working on a project, we develop a business case in which we compare the benefit to the cost, and we make sure that the benefits of the projects outweigh the cost. In other words, we just ensure or make sure that the project is feasible or justified. If the project is feasible and justified, we develop the first document of the project, and that's probably one of the very important document, and that's what we call it project charter. Project charter is a high-level document in which we are able to basically, it's like a birth certificate of the project, which is usually written from a high level. And that's basically, it's announcing that the project is initiated or started. Once the project charter is usually done, we start gathering requirements and information that will help me determining the scope of work of the project. We start implementing the project we start defining the scope of the project based on the requirement. The requirement does not necessarily mean the scope. There are two different things. The requirement is what I like to call it the voice of the customer, or what exactly the customer would like to have. The scope is what we are giving the customer. So there's usually a difference between those two. There are two different documents, and they are basically very linked to each other. We cannot do the scope without having the requirements. However, they are not the same thing. A lot of people misunderstand or basically confuse them together. After we define the scope of the project, which is, again, it's what I'm giving the customer, usually we start the planning phase in which we determine how we are going to be able to deliver this project. Once we're done from planning, we start the implementation and doing controls. And finally, once the project is implemented or executed, we go ahead and we do the transitioning and delivery for this project. So this is usually the classical way of looking at IT or managing IT projects. One of the most important part of IT project is requirements. Requirements normally is unique, if you will, in IT. And basic, as I said earlier, you cannot do the scope before understanding the requirement, what exactly it's looking for. In IT, especially projects, we have problems in gathering requirements. And the reason for that, a lot of time, the requirements are misunderstood. Many reasons. One of the reasons can be the customer sometimes give you their requirement in technical terms, which probably he doesn't really totally understand. Another reason we're having is sometimes the IT people jump into conclusion and do not listen to the customer very carefully. That's why we have sometimes, it's very common in IT project that we're having misunderstanding for the customer. Some statistics show that almost half of the project defects, that the problems that we have, it comes from the requirement phase. Requirements are usually, it's one of the most important part of, if you do it properly, then the chances of the success of the project increase dramatically. It's considered to be the skeleton of the scope of work. Requirements normally divided into business, functional, and non-functional. When we talk about business, we're talking about why do we need to do this project? What are the things that are different or unique? The size of the project, the budget of the project. What are, again, the things that we need to have in order to do the projects from business perspectives. Functional is we are describing the function of the solution, the basic function of the solution. So, for example, if we are talking about the printer, the basic function of the printer is to print paper. So it's describing of the requirements of what is this solution should do from functional perspective. Non-functional requirement is everything else, like all the characteristics that comes usually with the solution. So, scalability, if you will, availability, the color, the size, all those usually can be part of what we call it non-functional requirements. One of the important things that we need to understand is when we try to gather requirements and meet with the customer and having an interview with them in order to understand his requirement, we should really focus on the business requirement. Try to understand why, truly from business perspective, he wants this solution. Then after that, we can translate that business solution into functional and non-functional requirement that we can develop a solution for. As I said earlier, those are the problems that we normally face. The customer usually give you technical requirements without understanding them, or the technical team does not listen to the customer business problems, and that's why we face a lot of problems. What are the techniques that we normally use to gather requirements? Those are the common ones. I'm going to show you one of them actually a little bit more details. So interviewing is the most common one. That we see it all the time, and it's the easiest one, the most straightforward, and I think it gets you the best result. Just sit down with the stakeholders, the major stakeholders, or the key stakeholders, discuss with them, and gather exactly what they're looking for. If we sometimes we have a problem, we have a lot of customers, if you will, end users, and those end users are spread all over. So we cannot interview every end user. So another technique we can use is questionnaire or surveys, where we can design a questionnaire to collect their requirements. Another way to do it is prototyping. Show the customer a prototype, similar solution maybe, and collect his feedback, and accordingly you can adjust it accordingly. Another one, sometimes the customer is not sure what he's looking for, but he needs to improve in a certain area. So one of the things that we do, we can look at the documentations of the current system. We observe the current system and processes, how it works, and from that we can suggest something to the customer that help him improving. Process modeling, very common, especially for continuous improvement, where we need to model the current process and maybe re-engineer it, or maybe or improve it, like Kaizen it, or we call it, so improve it continuously, like little by little. And finally, other techniques that we can use in order to gather requirements is innovation games, which is one example of innovation game is, we call it remembering the future. Let's take a quick look on the remembering of the future. Remembering the future is we go back to the customer and tell them, listen, let's assume we are we are 6 months out, and imagine that we are done from this project, and we need to look back and describe the iteration, or we describe the release, or we describe the solution. So we assume that the project is successful, delivered successfully. We pass that delivery, and then we need to look back in order to describe the project, or the requirements, or the things that the way this project is working. It's really a nice way to look at it, and basically we use a lot of time post notes in order to help people to write their what the feature they're looking for, and then we can collect them and we can put them together as we group the things together under one tag or one title, and this is really actually really a very nice way to use, especially again if the requirement is not really well understood, or there's discrepancies between different stakeholders when we gather requirements. So that's one of the techniques that we're able to use. There are other techniques, of course, but this is one of the ones that actually I really do like. And after that, we started the project planning. Project planning, again, we're not going to go into a lot of detail. This is a really traditional or classical project management, so I'm not going to go through a lot of details. So, but again, we take the project scope and basically we decompose it using, we do the decomposition in order to get what we call a WBS, work breakdown structure. So we break down the scope into smaller pieces like activities and tasks, and then we determine the duration and the resources and the logic, the dependencies between these tasks. We put them in network diagram, and then we do critical path analysis, which is the longest path. And this is the one that we probably have to watch it very carefully. After that, we do Gantt chart and scheduling, and we do resource allocation and resource planning. In Agile project planning, it's a little bit different the way we do it. Again, Agile project planning is we do a progressive elaboration. We basically plan for the very next near future, and we leave everything after that from a high level. We create normally a vision. We size the features and basically the stories that we have, And then we have two different planning sessions. One of them is release planning for the whole release. And then within this release, we have multiple iterations, and we do also iteration planning. So the way we do agile planning is extremely different. It's actually totally different. It's not even related to traditional project management. After that, we're done from planning. We can go ahead and do implementation. Implementation, we manage our team, we manage schedule, cost, we test our product, and we manage changes. And finally, we do delivery for the project overall and transitioning. How to do delivery, and usually we have different, what they call it, cutovers, I guess. There is abrupt cutover where we stop the solution and start a new solution. Sometimes we do it parallel, where two solutions are going together, and then one is once with the new solution is proven okay, then we stop the other solution. There's different ways of doing this. You can do it geographically. So we start the new solution in one area, and when it proves success, we can go to another area and goes on. So this is a little bit brief, of course. We are here in Meirc. We do training for IT projects, and we discuss all those things in details. Definitely much more than this. We also we do IT projects. We give you like IT project management, where we cover a lot of things: planning, scheduling. We talk about transitioning. We start talking about delivering. We talk about a lot of different things, different methodologies, and a little bit more details. And this is it, I guess. So I'm gonna stop here. And if you have any questions, you can chat with me, I guess. I have Mr. Taysir Ismail. He said, "Thanks a lot. Could you please share the presentation with us?" Yes, it will be shared. I think they're gonna email you later on a copy of that presentation. If you have any questions, any other questions, please go ahead. We're gonna stay a few minutes here, and then we are going to discuss any questions you have. If not, we're gonna probably end it. So I'll stop here for a few seconds, see if you guys have any questions. Please post it on the chat room. Thank you guys. Thank you for attending. Just wanted for all of you, Mr. Ahmad and Mr. Ali and Mr. Roland, I guess. Thank you very much. I really appreciate your words. Thank you, Mr. Jimmy and Ms. Gita. I think that's it. I think we're going to go ahead and end up in this webinar. Still, you have a chance. You have my email. If you have any questions, you can always email me. And thank you very much. It was a pleasure, actually. And hope to see you guys later in other webinars. Have a great day, everyone. Bye-bye. Have a good weekend. Bye-bye.
Meirc.com